Hi guys, you are welcome once again to the Smart Way lectures on the Science Ambassadors series. This is a series of lectures we are running on all the areas in science, and today we are here with you to continue on chemistry. Now, in our last lectures, we were looking at some terminologies that will help us to be able to understand the concept of thermochemistry. Now, we look at some of the terms such as this: a system. Now we said that it is very important to understand these words because we will use it a lot. Now we also looked at some terms like surrounding. Now surrounding, these terms were very important for us to understand. Surrounding. Now what did we say about a system? It is very simple. You see, when you put water on fire, now all you are interested in is to make sure that the water boils so that you can use it for your tea or something. Okay, you are interested in boiling the water. Now you do not usually care about the surrounding, what is happening around it. But you see, it is very important that the water you are boiling is not isolated from the surrounding. But all you are interested in is to make sure that the water boils so that you want to use them. Now, because you are interested in boiling just the water, that part that you are interested in is what we call a system. So that's what we call a system. So a system is an object of discussion, an object under discussion, or an object of interest where you are interested in. That is what, when you say a system, that is an object of discussion. So reactions are performed in closed containers or in closed vessels or in open vessels, and so that reaction that are inside those vessels are what we call the system. When you are performing the reaction, the key thing we want is to produce a product so that we can bring it out for people to consume or use, and so that is where we are interested in. But see, we should have in mind that outside the system, there is the system that we want to call outside the system. The outside of the system is called the surrounding. That is the outside of the system. That's what we call the surrounding. Outside of the system. Okay? The outside of the system is what we call the surrounding. Now, this outside of the system influence the inside of the system. The outside, that is the surrounding, influence the inside. For instance, the heat you are using to heat your system is coming from the outside. It's coming from the outside, and so the dynamics, okay, must be studied. Whatever is outside is influencing whatever is inside, and so the system there's always a system. There's always what the surrounding of a system. So we said that now the outside of a system is what we call the surrounding. It has an effect or also affect the system. Now, we also said that when you say within a system, we have classified systems according to flow of energy into three. We said we have one, what we call an open system, a system that is open. That is when we are performing reactions and the vessels are open. Okay, an open system. This time around, you are boiling water in a silver and you've not covered it. And what will happen is that the system is affecting it. Okay. Affecting it. So if not covered, it's an open system. So when you say an open system, this time around, this is a system that allows both energy to move the boundary through the containers. Okay, so through the walls of the system. It is a system that allows energy or heat to move in, and also matter either to move in and out. So we define a system as an open system as a system with boundaries or walls that allow both energy and matter to move across its boundaries. We explained that. We also talked about what we call a closed system. We said that for a closed system, it is close to matter, but it's not close to energy. A closed system is close to matter, but it is not close to energy. So it means that in this system, the boundary allows the flow of energy in and out of it, but does not allow the flow of matter. I'm talking about solid, liquid, or gas. Now we also mentioned the term isolated system. Also mention the term isolated system. We say that the isolated system is isolated from both matter and what? Energy. That means that in this system, neither matter or energy, heat is allowed to be exchanged across the boundaries. This time around is isolated. A good example we mentioned was the thermoflask. The one we use to keep our hot porridge and water, or sometimes cooled water. So basically that is what we mentioned. Today we are going to continue this lecture by looking at the remaining part of the terms. We are going to take you through what is enthalpy. We are going to look at enthalpy. We are also going to look at not just enthalpy but also enthalpy change. So we're going to look at enthalpy change. And again, we are also going to look at not just the change, we are going to look at the standard enthalpy. We have something called standard enthalpy change. Standard enthalpy. So standard enthalpy change. So we are going to look at these things. So let's begin with the enthalpy. Now it is just a word. Don't confuse yourself. Enthalpy is just a word. Okay. Now what does this word represent? It just represents heat content. That is all. Enthalpy simply represents heat content. So enthalpy simply represents what? The heat content. So the heat content of a material. Heat content. Simply talking about heat content of a material or a body or a substance. The heat content of a material or a body or a substance. Or a substance. So that's what we call heat content. So most reactions are being performed and the heat content are being measured. For instance, our body carries a certain amount of heat. Our body carries a certain amount of heat. All material bodies carry a certain amount of heat. Have you gotten that? So far as you are not dead, you are alive, okay? You have some amount of internal energy. You have some amount of heat. You have some amount of heat in you, and so that is what we call heat content. But you see, I would advise you to be careful that when we say enthalpy, it is not just any heat content, but it is that heat content that we measure at a constant temperature, at a constant pressure. So the heat that we measure at a constant pressure. So heat content of a body at a constant pressure, or the heat content of a material, that is measured. The material that is what measured at constant pressure. That is measured at what? Constant pressure. Now it is very important because, as I said, not any heat is referred to as enthalpy, but the heat that is measured at constant pressure. Why are we saying that? Most reactions that we perform in the laboratory, we perform them under open system, subjected under the room conditions. Okay, so we perform them under room condition. That is, we leave the reaction vessels open and we perform the reaction at atmospheric condition or room condition. That's atmospheric condition. Now we should bear in mind that I told you that the atmosphere has the effect. The surrounding of a system has effect on the energy measured from the system. The surrounding of the system have effect on that measured in the system. The surrounding of a system have effect on whatever you measure inside the system. And so when we say enthalpy, it is the heat that we measure at a constant pressure. The heat that we measure at a constant pressure. Most chemical reactions are performed under atmosphere, under the condition of atmosphere. Under the atmosphere, we all know that atmosphere has a constant pressure of what? 1 atm, and also it also have a pressure, a temperature. Okay, it also has a temperature around the room. Temperature is usually around 25 degrees Celsius. Okay, 25 degrees Celsius. Now, which is equivalent to 289, which is equivalent to 298 Kelvin. Okay, so because reactions are performed in a laboratory under open systems subjected under the atmosphere, where we have a constant atmosphere, where we have a constant pressure of 1 atm and temperature of 25. What basically that's happening is that when we measure heat at a constant pressure, that is, if we keep the atmosphere constant, that is 1 atm, the heat that we measure from the system is what we call enthalpy. Okay, it's what we call enthalpy. So you should understand that heat, okay, enthalpy is simply the heat content of a material, but it is the heat that is measured at what? Constant pressure. Okay, so if you assume that if you perform your reaction at constant atmospheric pressure, that is of 1 atm, then the heat that you are talking about, the heat that you measure from your calorimeter, that heat is what we call the enthalpy. So it's very important for you to know that. Now let's now look at the enthalpy change. Let's now look at what we call the enthalpy change. Okay, good. So let's look at the next one called the enthalpy change. The enthalpy change. Now in chemistry, it is practically impossible to measure just the enthalpy of a system without measuring the enthalpy change of a system. So it is very important for us to understand this. You see, we cannot measure the absolute heat of a system. It is not possible. We are not able to measure the absolute heat of a system. Now, it is only the change in the heat that we measure. And so the change in the heat is now what we call the enthalpy change. Now, somebody would want to know why we do not measure the absolute heat or just the enthalpy of a system. That's what we call the absolute heat of a system. But rather we measure the change in what? In heat. Now, this would defy the laws of thermodynamics. It defies the laws of science. If we try to measure the absolute heat of a system, then some of the laws will have to break. Now, this is because of this. If you take a material like this, okay, if you take a material like this, so let me just give a color. If you take a material like this, now when you take a solid material like that, we know that matter consists of particles. Matter consists of particles, right? Good. For in solid, they are closely packed, and held by strong coercive force or attractive force. So this is the one that I have taken. This is just a solid I have taken. Now we cannot measure the absolute heat within the system. We cannot measure the absolute heat, or let's say the true heat of a system alone, without measuring the change in heat. Yes, so we do not measure the absolute enthalpy or the absolute heat of a system. This is because of this. This is what is working. Now, the particles of a solid are always not at rest. The particles of solid, we have found that the particles of solid are always vibrating. the particles of solid, liquid, and gas are always moving within the substance. So you see that these particles, atoms, molecules, and ions are always moving. Whether it is a solid, whether it's a liquid, whether it's a gas. For solids, the particles vibrate about their mean position, about a fixed position. They don't move about, but they vibrate. Okay, they vibrate there. They oscillate, or what I call they vibrate there. Now these particles are vibrating. Now it is this vibration of these particles that produce the heat that we are talking about. It is the vibration that produces the heat that we are talking about. Okay, and so because the particles are not at rest and always are vibrating, they are always vibrating. We can only measure the change in the heat, because the particles are not stopping. They are always vibrating, and the heat is always varying within the system. The heat within the system is always varying. If you want to measure the absolute heat of a system, then it means that we have to stop every motion of every particle, that is atoms, molecules, or ion within the system, which is practically impossible. It will defy the law of thermochemistry, that is specifically the law of entropy. Okay, so particles must be allowed to vibrate. Particles must be allowed. That freedom must be what? Must be attained. When again we try to do that, we also defy the Heisenberg uncertainty principle. We cannot say that particles are at rest, okay, because if we say that, means that we have lost the motion of the particle. So it means that we do not measure the absolute heat or the absolute enthalpy of a system, because particles are always moving and temperature is always varying, or heat is always varying. So we prefer to measure the change in the heat. That is what we call the enthalpy change. And so when we say enthalpy change, it is simply a change, okay, of heat that is measured, or the change in energy that is measured, or the difference in the energy that we measured, okay, that we measure from the initial state, between the initial state and the final state of the substance we are talking about, okay, of the substance we are talking about. So enthalpy change is the difference in the heat or energy, the difference in the heat or the energy that is measured between the initial state of the body and then the final state of the body. Between the initial and then the final state. That is what we mean by enthalpy change. But because in chemistry the initial is always reactant and final is always product, we define them according to that. So let's now give it the definition. So let's now give the definition in respect to chemistry, okay? In respect to chemistry. So what did we say? We said that we cannot measure the absolute heat of a system, because doing that means that we are freezing or seizing every motion of molecules, okay? Which is not possible, because laws will break down. Heisenberg uncertainty principle will break, and also the law of thermodynamics in terms of the law of entropy will also break down. So therefore, let's continue, okay, to find the enthalpy change of a system, okay, instead of trying to look for the absolute enthalpy by seizing all molecular motion. So enthalpy change. Now, as I said, because it's a change, then it means that there is an initial state and there is a final state. The difference in the energy, the difference in the enthalpy between the initial state and the final state, that is measured at conditions. Remember we told that enthalpy is measured at conditions, and so it's very important. Okay, so at a particular condition of pressure and temperature, the heat that you measure from a system is what we call the enthalpy change. That is the heat that we measure is what we call the enthalpy change. So enthalpy change, it is the difference, okay, in the enthalpy. It is the difference in the enthalpy that is measured, okay, the difference in the enthalpy that is measured between the reactants, okay, that is the initial state, and then the product, that is the final state, okay, between the initial and the product. Now at a particular atmosphere, at particular pressure and temperature, at a particular particular what? Pressure. Okay? At a particular pressure. But when you don't define the pressure, it means that you are losing the what? The surrounding. The surrounding has effect on whatever thing that you measure in. Okay? So at a particular pressure and the temperature. So that's what we call enthalpy change. So for instance, let me give you a typical example. Now it is represented like this. There is a sign, that is the enthalpy change. There's just the H, the enthalpy change. That's why it is represented. It's also called the delta H. It's also called the delta H. So the energy is the difference between the what we call the final state. Okay, difference between what we call the final state of the material from the initial state of the material. The initial state of the material. The initial state, the final state, and then the initial state. Okay. Now we know that in chemistry the final state is the product. The final state is the product. So the heat change of the product minus what? The heat change of the the reactant. Okay, of the reactant. The heat change of the product minus the heat change of the the reactant. So that is what we say enthalpy change is. So enthalpy change is the difference in the enthalpy between the reactant and the product, or between the initial state and the final state, that is measured at a particular pressure and temperature. And so mathematically that is how it is represented. So that is what we mean by that. Now quickly let me talk about the standard enthalpy change. Let me talk about the standard enthalpy change. Now when we talk of standard enthalpy change, the word standard means widely accepted. Standard means widely accepted, universally agreed upon. Now this is because, just as I said, that the atmosphere, the surrounding of a system always have effect on the energy that we measure within the system. And so therefore what happens is that if we do not specify the surrounding of a system, the energy or the enthalpy value or the enthalpy change that is measured at different conditions will vary. And so we cannot easily communicate. We cannot easily communicate with that. And so what we do is that we measure enthalpy at constant conditions, at constant or at standard conditions that is agreed upon by all scientists. Have you got that? And those standard conditions will always give you the exact or the same quantity of enthalpy. Okay, they will give you the same quantity of enthalpy, so as communication in science can be easier. So we are going to look at the standard enthalpy. So when you say standard enthalpy change, we are talking about the difference in the enthalpy of the reactant and the difference in the enthalpy of the reactant and and then the product, that is measured at standard conditions, not this time around, not a particular condition, but at standard or agreed conditions. Okay, at standard conditions. And so I'm going to look at some of the standard conditions under which we measure enthalpy change. Okay, we are going to look at the standard condition under which we measure enthalpy change. So quickly, let's look at that. We are talking about standard enthalpy change. Talking about standard enthalpy change. And we said that when we say standard enthalpy change, because enthalpy vary at different conditions, a standard is being chosen to always measure energy with respect to those standards. Okay, so with respect to those standards. So we are going to get that. Now what I want you to know is the standard, the agreed conditions. Now when we say standard conditions, we are talking about a pressure of 1 atm. That is atmospheric condition, a pressure of 1 atm. So that is a pressure. So standard conditions, when you say standard conditions, we are talking about condition of 1 atm. That is one pressure of 1 atm. Talking about pressure of 1 atm. So that is what we call standard condition. You cannot measure anything above or below this and then call it a standard condition. It's not done like that. And then temperature is also taken to be 25 degrees Celsius, that is normal room condition, or otherwise 298 what Kelvin. 298 Kelvin. This A1 ATM is the atmosphere, is the pressure of the atmosphere, and this 25 is the what temperature of the what of the atmosphere. That is the atmosphere, the room condition. And then here, which also equivalent to this. And then in case you are handling solutions, in case we are using solutions, then it means that we are going to talk about the concentration. Okay, when you say a standard concentration, we are talking about, if it is a standard, then you are talking about all solutions to be 1 mole, 1.0 what mole per dm cube. That is 1.0 mole per dm cube. That is what we mean by enthalpy change, and what standard enthalpy change. So all you should just understand is that when you say enthalpy, it is the heat content of a system that is measured at a particular what pressure. Just as I said, the pressure outside affects the heat inside, and so therefore measuring heat at constant pressure, okay, gives you a heat called enthalpy. The enthalpy change, as we said, that we cannot measure the absolute enthalpy of a system because we cannot stop molecular motion. So because temperature changes every time because of vibration, we prefer to measure what enthalpy change. And we said enthalpy change is the difference in the enthalpy between the reactant and the product that is measured at a given conditions or particular conditions. Okay, standard enthalpy change is considered because why? At condition, enthalpy varies at different conditions, and so a standard is chosen to measure all reactions with respect to those standards under 1 atm, under 25 degrees Celsius, or 298 Kelvin. And if you are dealing with liquid medium, then it means that the concentration or acid and base, the concentration of those things must be what 1 molar or 1 mole per dm cube. Now that is it. Just as I said, that the symbol for the enthalpy change is this. So please keep that in mind. The symbol for that is that, okay, that is enthalpy change is it. And then the standard, okay, the standard enthalpy change is indicated by this dot on top like this, and then there's a cross here. Okay, so I mean this. So the symbol for standard, you see somewhere like theta on top, 0, okay, and then just a 0 on top to just indicate that this is standard enthalpy, okay, and then this is what just enthalpy. No, sorry, this is just enthalpy change. Okay, this is just enthalpy change. So we'll end the lecture here, and in our next lectures we'll be talking about the characteristics of enthalpy change. Now that we know we are familiar with it, we are going to talk about the characteristics of enthalpy change. Thank you.